In this video, we find the center and radius of a sphere with a given equation. So, we're given the equation x squared plus y squared plus z squared plus 8x minus 6y plus 2z plus 17 equals 0, and we're being asked to find the center and radius of this sphere. One way that we can tell that it's a sphere and not some other type of surface in 3 dimensions is the fact that we've got x squared, y squared, z squared, so the x's are squared here, or excuse me, the variables are squared here, and all of the coefficients are equal. In fact, here they're all equal to 1, but the coefficients on each of these are all positive and equal to each other. When we have an equation like this, and then the other variables are linear, like so, we know we have an equation of a sphere. Alright, so our goal here is to figure out the center and the radius. To do that, we need to put this equation into standard form. The way we put an equation of a sphere into standard form is by completing the square. So, the first thing we're going to do is we're going to gather our terms together with the same variable. So, gathering the x's together, gathering the y's together, gathering the z's together, and then moving the constant to the other side. Because again, the standard form of an equation of a sphere has the radius squared on the right-hand side, so I might as well go ahead and just stick that constant on the other side. It's not necessary over on the left-hand side. Okay, so remembering how we complete the square, we look at the coefficient on the variable, we divide it by 2, and then we square it. What we're trying to make here is a perfect binomial square. The way we do that is we think about how a binomial squared distributes out. Remember, we get 2 times the coefficient, excuse me, 2 times the constant term as the coefficient on the variable term. And we're basically reversing that process. Alright, so again, we're going to take half of this coefficient and square it. Half of 8 is 4, squared gives us 16. And notice here now this factors as a perfect binomial square, right? This factors as x plus 4 quantity squared. That's why we add that 16 in there. And the reason why we're adding 16 again is because think about how this multiplies out. When you multiply this out, you get a 2. When you distribute it out, you get a 4x and a 4x when you do the distribution, when you do the FOILing, right? So you get that 8x. That's why we divide it by 2 to start with, because this 8x here represents 2 of those distributions of the same terms, because of the way it multiplies out. All right, let's look at the y's now. Half of 6 is 3, squared is 9, so we're going to add 9 in here. And again, we add that so that factors as a perfect binomial square. Half of 2 is 1, so we're going to add 1 in here, and then again this factors as a perfect binomial square. So on the left-hand side we have added 16, 9, and 1. Well, if I add it in on the left-hand side, I better also add it in on the right-hand side, keeping both sides equal. That simplifies to 9, so now we have this equation, x plus 4 quantity squared plus y minus 3 quantity squared plus z plus 1 quantity squared equals 9. This is the standard form of an equation of a sphere. We can now read the center and the radius off from this equation. The x-coordinate of the center will be a negative 4, y-coordinate will be 3, z-coordinate will be negative 1. Remember, the standard form is x minus whatever the coordinate is, so that's why this is a negative 4 and a negative 1 here. Because this is x minus a minus 4, z minus a minus 1. The radius is the square root of this number on the right-hand side. Remember, in the standard form, this is the radius squared. So in this case, we get 3.